Hey folks, Tracy here from RX AppDeg, Tracy Lewis Performance. We're going to today do something that I have not seen, and that's go through the different principles, processes, and designs to make an air oil separator work properly and effectively. Something most people don't even consider. They make their choices based on appearance, and even a beer can with a couple fittings is going to trap as much oil as, or more oil than a lot of these designs. So we're going to start off first with one of the early Mishimoto's. So any of these will trap some oil, but the real question no one wonders or asks or is curious about is what percentage of that total suspended oil vapors, combustion byproducts, the raw fuel, the water vapor, the acids, everything else, is separated, and how much simply just does a U-turn out of the can and is still ingested, doing very little actual benefit. Especially when you get into high compression and boost applications, you're going to have knock retard from the detonation pre-ignition that the still contained oils and other compounds are going to cause. So there were two fittings on the top. They're missing now, got taken off at one time and lost. One of these is an inlet, one is an outlet, and if you look in here, 90-some% of those vapors are going to just do a simple U-turn there and go right out and be ingested. There's nothing dispersing them through. There's no filtration. You're only using the condensing principle to condense into droplets, but since the vast majority of the vapors are just doing a U-turn and exiting right away, it's probably going to trap less than 15%. This did have a nice little feature of a sight glass, but they quickly discolor and they're not usable to really tell you anything. There's a brand new one. So these can still be bought from Alibaba for in the $4 to $6 range, and you can find 20, 30, 50 different brands that are put on them. Now we're going to go to a bigger design, and this is one of the more popular ones you'll see with different brands on them. Again, made in China. These sell for around $12. They may have gone up a little bit. Nothing inside there. Now we're going to look and see that vapors come in, do a U-turn, vapors go out. This is not going to work any different than this as far as effectiveness in removing the substances you don't want ingested. And if you're only removing 15, 16, 18% of those, it's not benefiting your engine hardly at all. It's all a placebo effect. And then this, of course, is an option to put a breather on here, which defeats the whole flushing and evacuation of these combustion byproducts that cause most wear and damage in your vehicle's engine, rather. We're going to move on now to one that looks a little fancier. You'll see these all over out there with different brands on them. Again, made in China. Another $8 to $10 can. But this one is eliminating even the condensing effect. So if you've got, this is your inlet, your vapors are coming in here, they're doing a U-turn and going right back out. The screen is doing nothing. If this was the inlet and this popped through the screen, you would get a little coalescing effect, and that would improve it, but not enough to be an effective solution. They've used a plastic resin to bond the three pieces together. And quite common, you're going to find that the bonding didn't bond, and that created a vacuum leak. So that's never good. And this insulates, so it keeps your internal operating temperatures at their 220, 250 degree range, as your normal oil and crankcase vapors are, all insulated in here, so the condensing principle is rendered pretty useless as well. So this is the least effective of any of them that we've tested. And we purchase these or get them somehow sent to us. We've had a lot of others as well, but most of them are these basic designs. Now we're going to move to a similar one to this. This one's called M7, but again, you'll find these with 20, 30, 50 different brands on them. Same thing, look them up on Alibaba.com. You can see how cheap they are. Oh, what are we seeing here? Same thing, vapors come in, do a U-turn, go right back out with no scientific principles of separating and turning those vapors back into droplets and containing them. And some of these sell $150, $250. And other than being something to look at, you're not getting much of any benefit out of these to your engine. Now we're going to move up to another Mishimoto, or again, these, there's real popular. It's small, it's attractive, and people think, oh, this is easier to install, and they don't give any thought again on effectiveness. You have to be close to 1 quart internal, which these are, before the speed of the vapors flowing through, or the velocity, can slow enough to not pull the droplets that form right back out. So these are horrible being that small. The design is vapors come in here. There is a water separating coalescing filter that isn't designed for oils, especially not from a crankcase, because the sludge that builds up clogs these in no time. You can't blow through it. It's completely clogged, doing nothing. And the corrosion, because this mild steel piece here that's supposed to be a deflector, are all rusting and falling apart as well. So nothing good can come from this, but it will trap somewhere in that 16%, 18% range. Still, the vast majority being ingested. Now, this one, the company that installed this had this going back into the crankcase, so you didn't have to drain the can. You're putting that oil back where it belongs in the crankcase, is their statement on their website. But you never want to put a concentration that on average is 70% water and acids, 23% raw fuel, and only 7% is on average oil. And that oil is saturated with abrasive particulate matter, your soot, ash, and carbon deposits. So that's the worst thing you could do to your engine, is put this crap that destroys and wears your engine back into the crankcase. So As you can see so far, nothing that we have covered, is there any science or actual design into these that is effective. Now, we'll go here, and you will see all sorts of brands using this. This one's just called Oil Catch Can, but as you can see, comes from the same manufacturer in China as this. And when we open this, again, it's too small internal volume. This is marked as an inlet, and that inlet goes through this supposed baffle, which this plastic piece does nothing. And there are a couple people that will cut that open or pry it open and put some scouring pad material in there, which does work to coalesce. But since it's too small to slow the rate of the flow, the droplets falling out of here, most of them just do a U-turn and are drawn out the outlet and still into your intake air charge and doing little or nothing to benefit. Now, when we go to one of these brands, and again, these are probably $8 to $12 now in Alibaba. The function of the PCV system, only a small amount of it has to do with pollution control. And in the beginning, it was designed for pollution control for the water runoff and the contamination of the groundwater, not air pollution. That came along a little later. But you have one portion of your crankcase has filtered fresh, if equipped, mass airflow metered air coming in to one portion, being drawn through and flushing and making up for the contaminant-laden vapors being evacuated or sucked out the opposite portion of that crankcase. Or if it's a V configuration, V6, V8, V10, V12, you're going to be pulling it out of the opposite bank. You're going to have filtered fresh mass airflow metered air coming in one bank, traveling through the whole crankcase, making up for flushing the contaminant-laden vapors being drawn out. Now, when you mix that clean side and the foul side together, you've defeated that entire process, and you're leaving the majority of the contaminants in the crankcase to mix with the engine oil, which is, again, one of the worst things you can do. It's defeated the beneficial functions of that. Crankcase pressure should be dealt with by pulling vacuum and not venting. Again, so this also greatly decreases the removal of any of that oil-laden vapors. So this is not a benefit in any way to the engine. And most of these companies I've contacted and tried to share the information and tips on how to improve theirs, but usually that's met with pretty rude replies. Okay, we've covered these. We're going to move on now to, again, one of the most common, especially when you're in the Ford and the Mopar crowd. Each of these, and usually a lot of times you can take them apart and the threads and the upper and lowers all fit together. This one is made in China, where these, I believe, are mainly made in the U.S. This is the billet technology or billet prototypes. And quality machined, attractive looking, but near worthless again in preventing that knock retard and the detonation and the other bad things for the engine that come from ingesting this gunk. So this one, there's no dedicated inlet or outlet. So we're going to look into the inside, and we can see here there's nothing down here, so that's going to contain it. And we pull this screen out, and we see there's stainless scouring pad media, which does a good job of coalescing. But the problem is, again, approximately half the internal volume that's needed for the rate of flow from the average PCV system to slow to the point that you're not pulling most of the vapors out, or most of the droplets back out. And here's the flaw with this design. Let's say this is our inlet, and your contaminant-laden vapors are coming in, and they're going through this media here that does a pretty decent job of coalescing the vapors back into droplets, and the droplets start to fall out of this side. Well, the majority of them are simply going to do a U-turn and be drawn right back in. You really need about 3 inches minimum to prevent the Bernoulli effect of lifting those droplets and bringing them back in with the flow. So the majority of your oil and other contaminants are passing right through. Now here's the worst thing about this, is it won't collect much while the engine's running and the flow's going through. But when you shut the car down, the oil that was saturated in these is going to drip down, and that's what you're seeing when you drain it and think it's doing a good job. The other thing is, see how this is tight against the exit? Now, if we take a wet washcloth and place it to our mouth and suck on it, you're going to draw water right out of that washcloth. Well, the suction here is many times stronger than you would with your mouth. And so when this gets saturated, you're just sucking almost all of that oil and other contaminants directly out to still be ingested. So we pointed out the different design flaws and how the different scientific principles work or don't work. So we're going to go in here and take one of these apart. And we're going to see that although this is a little bit more precise in its machining and manufacture than that one, which leads me to believe it is made in the U.S., and that is one of the claims. The screen, which is the same, and the chambers which are the same, and the fittings, which are the same, and no designated inlet or outlet, it's going to do the same thing. The only difference is, instead of being held in by screwing the bottom in like this, there's 2 little stainless, which again is quality, Allen head screws that hold it, but it's the same internals, the same media, and the same principles. And you'll see most of your Mopar guys, even if they're running 1,000 horsepower Hellcat or Trackhawk, have these on there, which are doing basically nothing to benefit their engine or reduce the knock retard from the detonation that it's experiencing. But they look nice and they're small, and you'll see they're popular. So again, no one wonders what they're doing. Now, we get quite a few of these come through. Either people send them to us or we put a proper system on. So you can see there are different ways to mount them and such, but they're all the same there. Now, this is very similar, just slightly larger. But inside, and this is the Elite, basic Elite catch can, which is their original design, has been around forever, and has always been one of the better small compact ones. And this is where we see the difference. This is the inlet, this is the outlet. So this does not have those two side-by-side chambers. It has the one chamber with the coalescing media in it, which is quite large. It goes all the way up in here. And so this will do a pretty decent job of coalescing and turning these into droplets. When they're dropping, if you look at going from here up to the inside of this, you've got maybe 1.5 inches, close to 2 inches. So there still is going to be some pull through from that, but 2 to 3 times more effective than these designs, even though they look almost identical. So this is appropriate for your mild NA engine or a daily driver, as long as it's port injection. This isn't an effective enough design for direct injection because direct injection can tolerate no oil ingestion without negatives. And of course, they didn't have, the port injection engines didn't have that fuel dilution issue. From there, I've got one final one that should get mentioned. Seiko Michi. This is, although too small, this is the dual can system, so you could have one end on the clean side, one end on the dirty side, but you can't use it as a full-time evacuation system. But the design in here, you've got a center down tube inlet that's perforated and dispersed into a series of coalescing media. It doesn't have separate chambers and baffles and such to make the best use of each of the separation principles and containment principles. But I believe it's been many years since we did the testing. This came in one of the most effective out of the ineffective cans. I think this got close to 40%. So many times more effective than any of these designs here. And now we'll go to our patented design. And all I have today is just one of the standard size cans. It's nearly the 1 quart, which is what's needed for internal volume. And this is a full-time vacuum system, which we'll go into here in a minute.
Here.
Your incoming oil and contaminant-laden vapors enter the center. They go down through this dispersion tube, and inside here it's all perforated, and we have the stainless coalescing media inside. So we're dispersing all of that inside this primary coalescing chamber. And that does better than any of these other designs with just our first step. Once it comes out here, we've got droplets, and those vapor, the droplets will stay in the bottom in the containment section, while the vapors will travel equally around the lower disc baffle. And as you can see, we have a 1/8 inch space uniformly around, so those hot vapors make the most complete contact with the outer wall of the main separator, so you're getting the maximum temperature differential for condensing. and the vapors will slow a bit as it gets into the secondary condensing chamber. The bottom portion here is a primary condensing and containment chamber. And from there, the vapors slow here, so any other droplets can fall out of suspension and then work their way down. And then again, they are squeezed and go through that same gap and cool one more time before they enter a totally separate outlet chamber where they can slow one more time before exiting. Now you'll notice we've got approximately 9-10 inches of total travel through the standard can, even more through the Monster, which is twice this capacity. And it is going to use intake manifold vacuum for evacuation when it is present. We have the special billet high flow positive closing check valves. That was a development from Elite Engineering, and which we do a good deal of the design and manufacturing for. The second outlet will run through a one-way check valve to a Venturi vacuum generator. And that Venturi vacuum generator, tongue-tied there, is going to provide the vacuum when there is none present in the intake manifold. Now, naturally aspirated engine, you're going to have no usable vacuum anytime your throttle blade is open. The cam overlap reversion pulses are going to come back up through, and they're going to cancel any usable vacuum. That's where the average catch can is just going to allow pressure to build. And that's why you see people incorrectly putting breathers on or opening the crankcase where they're defeating the benefits. And that will take over. In the faster the incoming airflow, meaning the greater your throttle is open and the higher the RPMs, the more vacuum is generated. And at all times, this is pulling vacuum suction on the crankcase. It's the only one of its kind design. It's patented. And this is an actual true vacuum system, a true evacuation system, and a true air oil separator. This is approximately 95% plus effective through all those processes, and the incoming vapors never mix or commingle with the outgoing vapors. Again, the only design that does this, and proven with approximately 24,000 of these out in use, especially in forced induction. There's nothing that compares. So, and we challenge anyone to do the back-to-back testing of any can design against ours. There's plenty of videos online for these. Garage King has done a series of them. He does a good job. So the other thing we're doing is no one is addressing the clean or the fresh side of the crankcase evac system. So this is our clean side separator. Some people are familiar with these, with the LS engines. There's a plastic clean side box that was an option for the 1LE performance package. What this does is just separates oil from the clean side in the event that any oil-laden vapors are pushed back up through. And the GM plastic one has no filtration, condensing, anything. And the problem with the new LT 6.2 GDI engines they are returning that, and on the Camaros, the Corvettes, there's not room. They have a little clean side box that works pretty well. Comes off pretty much the cylinder head on the passenger side. So this replaces all of this included in these kits, replaces the oil fill cap. Once this is put on, it doesn't need to be taken off. It just seals together. You turn clockwise, pull to take it off or put it back on. And so we're the only system that is addressing both major points of oil ingestion. Only about 15% of that oil ingestion comes through the clean side, but our goal is to stop as much of it as possible. So, leaving it there, ask questions. We're going to continue this series and go on technical aspects of the benefits for regular day-to-day daily driver engines all the way to race engines, and go over that as well. But I hope this is educational, and somehow we're trying to get people to use their brain and question how well does that work. Just because it traps oil, which is how the vast majority are making their decisions, that has nothing to do with how much of that suspension is removed. Talk to you later.